So today I will start digital electronics. So introduction to digital. First, in digital electronics, why number system comes into picture. In computer system, can only understand the binary numbers. Okay, what is that computers made up of? Normally computers are made up of series of switches, and each switch has two states, either on state or off state. And again, each state can be represented by either 1 or 0. Okay. And 1 is represented for on and 0 is represented for off. Then comes to number system. These number systems includes 4 main number system. One is called binary number system. Next comes decimal number system. Next comes octal number system, and the last one is called as a hexadecimal number system. Okay. And each number system is represented by its base. What is base? In binary number systems, only two numbers are there, either 1 and 0. And since two numbers are included, that's why the base is represented as 2. Similarly, for decimal number systems, there are 10 different numbers, 0 to up to 9. That's why its base is represented as 10. Similarly, in octal number system, it is 0 to 7. If you count, 8 numbers are there. Here 0 is also included. We cannot ignore 0. That's why since 8 number systems are there, so its base is 8. Similarly, in a hexa number system, first of all, the numbers are 0 to 9, which consists of 10. And then it starts with A to F. Here 10 digits and here 6 alphabets, which includes 16 things, and this is called as a base 16. The hexadecimal number system is otherwise called as alphanumeric number system. Why it is called alphanumeric number system? Because it consists of alphabets, that is from A to F, as well as it consists of numerals, that is 0 to 9. That's why it is called as alphanumeric number system. But here A to F is again represented as A, B, C, D, E, F. 6 alphabets are there. A is represented as 10, B is represented as 11, C is represented as 12, then 13, then 14, then 15, up to 15. So these are the 4 number systems that we are using in digital electronics, with base 2, with base 10, 8 and 16. Then, after knowing these number systems, our primary motto is to how these conversions are done, how the machine will learn, because we the human can understand all these 4 number system, but machine can understand its own language. That means our computer can understand only binary, so it needs some conversion. Okay. Then first of all comes to decimal conversion. What do you mean by decimal conversion? That means from decimal number system, I want to convert it to binary, I want to convert it to octal, I want to convert it to hexa. Okay, so decimal number system is there and I want to convert to binary, to octal and to hexa. So how it can be done? We will do one after another. So let's start. First one is decimal number system to binary number system. Okay. So the best example, if I want to give you, let it is 56.25. Here the numbers are 5, 6 to 5, all comes under. But this number system can be octal number system, it can be hexadecimal number system. That's why you have to put the base. And if I am putting the base 1010, it is understood that it is a decimal number system. And I want to convert it to binary. So what is the step for this? The step for this is you have to divide this 56 by whatever number has been asked. You want to convert it to binary, so you have to divide it 2. And from the decimal point, that is 2, 5, you have to multiply with 2. This is the step. So first, I want to divide 56 with 2. The result is coming as, if you divide 56 with 2, then it is coming as 28. Then whatever remainder, either 1 or 0, you have to write here. Here the remainder is 0. Then again you divide with 2. You have every time you have to divide with this binary, because it has been asked decimal to binary. If it has been asked decimal to octal, then you have to divide it to 8. If it has been asked from decimal to hexa, then you have to divide with 16. Same here to 14. Again the remainder, it is coming as 0. Then 2, 7, 14. Here again the remainder is coming as 0. Then 2, here it is coming as remainder 1. Then last, again the remainder is coming as 1. So our numbers are what? The remainder here it is coming as 0, then 0, then 0, then 1, then 1, then last is 1. So while writing the binary portion, while writing the result, it will be from bottom to top. That means my 56 binary has been converted to here 1, 1, 1, triple 0. Is it okay now? Then comes 0.25. What you will be doing 0.25? 0.25 into 2. That means if you divide 0.25, it is coming as 0.50. Now whatever this is, before decimal, you store it as 0, then again you convert 0.50 into 2. You will be getting as, then again you have to store 1, again this 0. This stops because whenever you multiply 0 with something, again the result is coming as 0. Now the answer what you will be writing for decimal is from top to bottom. That means 0.25 decimal is, the answer is 0, 1. Okay. Now you add these two results, then your answer will be 1, 1, 1, 0, 0, 0, triple 0, 0.01. Now every number is represented as 1 and 0. Now this tells you that your decimal has been converted to binary number system. In this manner you can give any example and you can solve decimal to binary number system. Then comes decimal to octal. Only I changed binary to octal. Same principle. Our requirement is I have to convert it to octal number system. So same 56.25 I am taking. So the procedure is you have to multiply with, you have to divide 56 with 8 and 0.25 you have to multiply with 8. The answer will be in octal number system. If you want to check, then I am checking 56 divided by 8. So what is the answer for 56 divided by 8? So 8, 7, then remainder is coming as 0. So no more division is possible. So your answer will be for 56 decimal, your octal will be coming as same principle, bottom to top. So this is 7 and 0. And 7 is an octal number system, no doubt. You are getting here. Again 0.25. Same principle, 0.25 into 8 you have to do. That means 8 4 are 40, 16. This is coming as 2.00. So here 2 you will store 2. Again here it is coming as 00. So no further multiplication. So your answer is 70.2 octal number system. So I hope the decimal to octal is clear. Now decimal to hexa. Let me tell you same principle. If you want to convert any decimal number system to hexadecimal number system, same, you have to divide with the 16 and multiply with the 16. So this finished our decimal to octal, decimal to binary and decimal to hexa. Then comes binary conversion. That means I want to convert binary to decimal number system, binary to octal number system and binary to hexa. Let me clear you. If you complete the decimal to other conversion and binary to other conversion, then octal to hexa, this conversion is very easy. So first of all, binary to decimal. So any example if you want to give binary to decimal number system, suppose for example 11010.11. This is my binary number system. Here also we are having this whole number and this is our decimal number. So how to convert this? Here the procedure is little bit different. Whatever base is our, that we need to multiply with its value. And let me tell you, before decimal point, this is treated as 0 position, this is treated as 1, this is treated as 2, this is treated as 3 and this is treated as 4. Similarly, after decimal point, it is treated as -1 and it is treated as -2. After knowing the place, you can start doing the conversion. How? First you see, here it is written as 1, so you write 1 into, what it is there? It is there binary to decimal conversion. So whatever base is that, you have to multiply 2 to the power its value, 2 to the power 4. Similarly, plus 1 into 2 to the power 3, plus 0 into 2 to the power 2, plus 1 into 2 to the power 1, plus 0 into 2 to the power 0, plus decimal comes, so you write 1 into 2 to the power -1 plus 1 into 2 to the power -2. Here the base is 2, that's why I have to multiply with 2 with its value, place value. Now the result, it will be coming, if you multiply everything, it is coming as 26.75. So binary to decimal, and from here also I can give another conclusion that if you want to convert octal to decimal and hexa decimal to decimal, the principle is or the procedure is, here binary is there, that's why you are multiplying with 2. If this is the same example, for octal also you have to multiply with the 8 and for hexa you need to multiply with 16, but the procedure remains same. For example, if you want to convert any octal number system, let it be 27.21. If this is my octal number system, then how I will do to its decimal? The procedure is same principle. This is 0 value, this is 1 value, this is -1 and this is -2. That means you have to multiply 2 into 8 to the power 1 plus 7 into 8 to the power 0 plus 2 into 8 to the power -1 plus 1 into 8 to the power -2. In this manner you have to do. So any decimal, it may be octal to decimal, it may be hexa to decimal or it may be binary. The procedure is in this way. Okay. Then comes this one. How to convert binary to octal. This is very interesting one, and binary So how to do? So let's start with one example, that is binary to octal number system. In binary to octal number system, what is the procedure? So give me one example. So let's start with one example. Let it be like this: 1 0 1 0 1 1 1. 0.100. So whenever you want to calculate or you want to convert binary to octal, the procedure is you have to start with the 0 position and you have to group these bits by 3. How? First you take this 3 at a time, this 3 at a time. Now only 1 left. So what to do? So if 1 left, I will just add to 0. And it will not hamper my number, because for example, if I write 2, this is also right. If I write 0 2, this is also right. And if I write 0 0 2, this is also right. So whenever you add the 0, okay, towards left, it doesn't hamper my number. Same principle here. So if only 1 left, to group it by bit by 3, I have to add 2 zeros. Now this becomes 3. And here already 3 bits are there, so no problem. You can add this or you can group these bits by 3. For example, if another number is there, here what you will do? You add another 2. Now its 0.2 is same as 0.20. It is also same as 0.200. The same principle here also, so no problem. So now the number here it is represented as 1 2 7. How? This is represented as 1. 0 1 0 is represented as 2. 1 1 is represented as 7. And this is represented as 4. So this is 1 to 7.4 and this is an octal. Again I am recalling it. Whenever you want to convert binary to octal number system, you have to group the bits by 3. And if it is binary to hexadecimal number system, the principle is same, but you have to group it by 4. Same, not by 3, rather by 4. How? 1, 2, 3, 4, make it 4. 1, 2, 3, so 1, 0 if you want. So now this becomes. Okay. Similarly, here only 3 bits are there. So I can add another 0, it doesn't hamper. And I will put as a 4 groups. Sorry, I have to group 4 bits. And here the result is 101. What is? This is 5, this is 7 and this is 8. So 57.8 hexadecimal number system. Okay, so what we did today? We did decimal to binary, decimal to octal, decimal to hexa. Second, what we did? Binary to decimal number system, binary to octal and binary to hexa. Now if I move to octal to decimal, octal to binary and octal to hexa. Just now I said, whenever you want to convert any number system to a decimal or number system, the principle is you have to multiply with 8. Okay, and octal to binary, what you do? Suppose 27 is the octal number system, and first you convert it to decimal, that you know. And after converting it to the decimal, you convert it to binary, because you know decimal to binary conversion. Similarly, for octal to hexa, first you convert octal to decimal. After knowing the answer for decimal, you convert it to hexa. That's why binary conversion and decimal conversion is very, very important. Once you do the conversion for decimal and for binary, other octal and hexadecimal number system can be converted automatically. So this finished your number system and its conversion. Okay. So now you can see system, we are having the decimal 0 to 16, and for each decimal number system is converted to binary. From the binary you now convert it to octal. Again from the binary you can convert it to hexa. You may convert a octal to hexa, but it is not directly done. So better first octal to binary, and from the binary you find the decimal number system.